Hi, my name is Amadou Jalop, and today we're gonna take chapter 1 outside the classroom. And chapter 1 is the introduction of material science and engineering. So in this video, we're going to see the historical perspective of material science and engineering, the definition of material science and engineering, why we study material science and engineering, some of the classifications and types of material science and engineering, and we're gonna see the advanced topics like advanced materials, nanotechnology, biomaterials, smart materials. We're gonna see the classification and processing of material science and engineering. So we start with the historical perspective. If we go back according to history, every ancient time was given the name according to the material that they discover at the time, and they start using that material. For example, if we go back to the Stone Age, and that's the time when our ancestors discover the use of stone. So they start using stone to build houses, and they start using stones to hunt for food, and so on and so forth. And also we have the Iron Age. The Iron Age is the time our ancestors discover iron, and they were able to use iron in various uses. And we have the Bronze Age. The Bronze Age is the time when they discover how to engineer materials, iron and copper. When they combine it, they to get what we call bronze. So that's just brief history about material science and engineering, date back to the Stone Age. And now we see what material science and engineering is. So let's define material science. Material science is the study of the structures and properties of a material, wherein material engineering is after studying these structures and properties, we move one step further to understand this and create other materials to meet our daily demands. So types of materials. We have basically 4 primary types of materials, and these are metals, ceramics, polymers, and composite materials. Metals, examples of metals are iron, vanadium, tungsten. Most times the element in the periodic table, those transition elements, are considered metals. Ceramics are between metals and non-metals, and most times the oxides, for example, aluminium oxide, magnesium oxide. And also we have examples of ceramics like pottery, and another example will be cement, but cement is also considered to be a composite material as well. So for a basic understanding of all this, we're gonna require a little bit of chemistry. And also polymers are these hydrocarbons, polymer chains molecules. That's the example of polymers. And composite materials is the combination of the polymer and ceramic materials, or ceramic materials and metals. Now we move on to the classification of properties of materials. In material science and engineering, we have 4 components. We have what we call processing, structure, properties, and performance of a material. These are the 4 components we consider whenever we are choosing a material for a particular purpose. And these 4 components are related to one another. For example, the performance or the use of a material highly depend on the properties of that material. And the property of a material depends on the structure of that material, starting from the microscopic level. And the structure of a material is dependent on the processing, how we process this material, how we fabricate this material. That's how we get the structure. So you can see that these 4 components are highly interrelated. So for example, if we take steel, to process, we have to consider all these 4 components in order for us to able to process steel. So actually the main concern of these 4 components are the properties of a material, and these properties we divided them into 6 main categories. There are other properties as well, but these are considered the main ones. For example, we have what we call mechanical properties, we have the electrical properties, we have the thermal properties, we have the magnetic properties, we have the optical properties, and the deteriorative or corrosion. So how a material is classified depends highly on their properties. How we use a material depends highly on the property of that material. And also we have what we call advanced materials. These are nanomaterials and the smart materials. We have what we call now nanotechnology, and also in the medical field, biomaterials. And in one of my videos, one of my previous videos, I talked extensively, then I showed examples of materials that we use in our daily lives, ranging from glass, aeroplane, cars, our mobile phones, televisions, TV stations. All these materials or all these technologies are made possible as a result of understanding material science and engineering. So basically that's the introductory part of material science and engineering, the chapter 1. In chapter 2 we're going to start looking at the chemistry side of it. We look at the atomic structures and bonding, how these are related. So we start building it from atomic scales all the way to the macroscopic level. So join me, subscribe to my YouTube channel so that you cannot miss any lectures both inside the classroom and outside the classroom of material science and engineering. And I hope you understand the basic concept. Yes, this is the introductory side of it. And until then, see you in the next video. Bye for now.